Okay, right now I'm gonna solve the problem 10.1, which is finding the torque for each cases. And for that, we know that the force is 16 newtons, the force applied to this door, and the radius will be this distance, which is 4 meters. And the torque formula says the torque is equal to the force times the radius times the sine theta or angle theta formed by the horizontal x-axis and the force. So step number one for the part A, this is the hinge, this is the door, and this is the force applies to the door and an angle of 90 degrees. The first thing that we're gonna do is translate this force up here, and we put the x-axis over here. So, and this angle over here is 90 degrees. So we can apply the formula. Torque is going to be equal to the force, which is 16 newtons, times the radius, which is this, 4 meters, from the hinge to the applied force side, 4 meters, times sine of 90 degrees, which is this angle. So, and this is going to be equal to 64 newtons per meters on the first case. Then we have to find the direction of the torque. Since this force is applying in this direction, what it's gonna do is gonna do this to the door. It's gonna rotate it counter clockwise, which is mean as a positive direction. And positive direction is out of the page. Okay, this is for part A. Part B is pretty similar. We have the hinge, the door, the force, 120 degrees. So we translate the force over here. And this is the horizontal line with the x-axis, which is this 120 degrees. And we find torque again. Torque is equal to 16 newtons times the distance, which is 4 meters, times sine of 120 degrees, and this is equal to 55.4 newtons per meter. And again, because the force is applied in this direction to the door, so it's going to rotate the door this way, again counter clockwise, which is a positive direction out of the page. Similarly, we have the case C, or letter C, which again you're going to translate the force over here with the x-axis, and the angle over here is 30 degrees. The distance from the hinge of the door to the force applied again is the same, 4 meters. So torque is going to be equal to 16 newtons times 4 meters times sine of 30 degrees, and this is going to be equal to 32 newtons per meter. And again, this is the door, this is the force, and make this rotation again counter clockwise, positive direction out of the page. Okay, now for the part D of the same problem, we have this door. This is the hinges, this is the door, and the ply for it's in the middle of the door and an angle of 60 degrees. So what are we gonna do is translate the force over here, and this is the x-axis. So this is 60 degrees, meaning that the torque in this case is gonna be 16 newtons times 2 meters, because that's the distance that is applied the force at, times sine of 60 degrees, which is equal to 27.7 newtons per meter. Now, in this case, the direction of the force, it's this way, like that way, which is clockwise. Clockwise, negative direction, and for the hand rule, it will be into the page. Okay, this is for part D. For part F, we have the door and the hinge over here, but in this case, the force is applied directly at the hinge. And since the force applied directly on the hinges of the doors, the distance where the force is applied is 0. So torque is going to be as follows: 16 newtons times 0 meters times whatever angle is made. And because this is 0, everything is 0. So torque is 0. There is no direction. And similarly, for the last part, which is F, the force F, it's in the opposite direction of the hinge of the door, making an angle of 180 degrees. So torque in this case is going to be 16 newtons times 4 meters, which is the total distance of the door, times sine of 180 degrees, which is equal to 0, meaning that as well for this case, torque is equal to 0. And that's it for the problem. Thank you.